Okay, hello to all of you. This will be some interesting days working on this REMP, and interesting to test out how it will be to be in a 2-week virtual workshop. Never tried that before, but I'm sure it will be interesting. I have participated in 2 of the workshops leading up to this one, the one in Paris in May 19 and the one in Évora just a year ago. And I was looking forward to meet you all this time again, but we'll have to save that to another time. So thank you for having me here. I will, in this talk, try to provide some examples on how we work and where we see technology development as an integrated part of our environmental management. But first, a few words on who we are as a company, for those of you who don't know us yet. In Equinor, we are transforming our company to support and accelerate the energy transition, the needed energy transition, and at the same time ensure that we have a competitive and resilient business model. And we want to do that in line with the Paris Agreement. We are committed to preventing harm to the environment, and we support the UN Sustainable Goals. We have already brought CO2 emissions in the oil and gas production down to industry-leading levels, and we will continue to do more. We will grow our renewable energy capacity tenfold by 2026, and we aim to develop as a global offshore wind major. By 2050, we aim to become a net zero company, including emissions from both production and final consumption of the energy we produce. Our journey to develop as a broad energy company is founded on a strong commitment to sustainability, and our strategy, always safe, high value, and low carbon, is applied in everything we do. Then to some examples on how we work. This slide will become a bit busy, but I still think the timeline it represents of a project is valid. And I think I'll be able to run you through it. You explore, you study if it's feasible, what you have found, you select your concept, you make a final investment decision or an FID, you build, and finally you enter into operations or run the plant or facility. And the bullets mentioned here represents important elements of environmental management for a project. I will not go through all of these because that would take most of the time we have allocated here, but I'll highlight the ones or some of them relevant for how we work on technology development and how we integrate that into the overall environmental management. If you understand your challenges early in the process, it is much easier and far less expensive to mitigate them compared to if they show up late in the process. So do an early phase risk and impact assessment. Try to understand the causes and sources of risk. And when you have a feasible concept, assess the need for enabling and enhancing technologies. And that's what I will try to provide a few examples on in the coming slides. We can easily agree that we still have a number of uncertainties regarding potential impact from deep sea mining of polymetallic sulfides on the Mid-Atlantic Ridge or from wherever as a fact. And the main ones I guess we could agree on. And those could be described as the impact from spreading of toxic and particle-rich sediment and return water plumes, and also that we need an improved understanding of the relevant ecosystem. And I mentioned both of these because that also comes back to the definition of environment technology, or of technology as such. That is not just about machines and hardware, it's also about knowledge and competence building and models and so on. And the first one is related to development of knowledge, not so much hardware. But one example is this one, to reduce the knowledge gap. This is the main content of an application towards the Norwegian Research Council for a 3-year research program. And this program is developed together with the University of Bergen and NORS in Norway and NIOS from the Netherlands. It will cover both fieldwork and lab work, as well as desktop studies. It will cover work on benthic communities, ecosystem function, connectivity studies, plume and toxicity, better understanding of those, as well as suggestion for a risk framework. Another knowledge building example is shown here. We have participated in a project together with Equinor under the Equinor project, with the aim to better understand the resilience following a disturbance, as well as species composition and connectivity between SMS or PMS deposits. This is a project that is about to be completed. We have also entered into an agreement with Ifremer to participate in the Blue Revolution project, which is about to start up. And it is an exciting and ambitious project, combining knowledge and experience from medical science, use of artificial and development of artificial intelligence, and biology, to mention a few, and which really could bring us a significant step forward on benthic taxonomy and increase the much needed efficiency on how to process samples. I would also like to mention this one. Now comes 2 examples, which is more on the tools and hardware side. This is the Louvre Ocean Observatory project. The first node of this observatory was put in place already in 2013 off the coast of Lofoten and Vesterålen in northern Norway, hence the acronym louvre. The other nodes were put in place during 2019 and 20. We in Equinor funded the land infrastructure of this, and we also funded the first node. The rest is funded by the Research Council of Norway, and Institute of Marine Research in Norway is the project manager. The objective for the Louvre Ocean Observatory is to improve our overall understanding of natural variations and build knowledge about marine ecosystems. And as you see, data is freely available at these wonderfully named websites. The reason for me to mention it here is that it provides a good example on technology that might be very useful for us going forward in deep sea mining. It's sensor-based, it's on platforms, and it's deep ocean. Another system we have been developing and tested the last 6 years is this underwater intervention drone, which also have an ability for subsea residence, meaning that it can stay on a docking station. Partners in this Allume project is together with us in Equinor. It's also Kongsberg and DNV GL. It has been extensively developed and tested over 6 years. The Allume is based on Lego concept, which means that you can adapt the vehicle configuration. So the robot, as you see here, you can adapt its configuration depending on the pursued purpose of a given task. So you can change the instrumentation, also subsea, and the Allume platform, as you see here, has been developed primarily towards our oil and gas industry, as being to be part of a primary monitoring system for an asset, data and early warning signals, and a number of relevant environmental instruments developed already and included in it, such as methane sniffer, CTD, fluorometer, camera, and profiling sonars. And a number of other sensors are being assessed to develop. So this again can I believe play a role, could be relevant for us to apply in relation to deep sea mining. So, final slide. Understand early what your main causes and sources of risk are, and assess relevant mitigating actions, and assess need for development of technology. The big one, as you have noticed, I haven't really talked about here, ways to reduce the amount of particles made from the mining operation itself, to minimize the indirect impact from the operation is obviously a focused area and something we also are working on, but I do not have a system to show you yet, hopefully in the future. But again, I hope I managed to convey some examples on how we see development of technology as part of, or as an integrated part of our overall environmental management. Thank you for your attention.